Hi, I am Srija. I am from CSD C-section department. Today I am here to speak about physics subject on the topic quantum networking and internet working. So introduction for this topic is quantum networking and internet working are emerging technologies that promise to revolutionize the way we communicate and process information. Quantum networking involves Quantum networking and internet working are emerging technologies that promise to revolutionize the way we communicate and process information. Quantum networking involves the transmission of quantum information over a network of quantum devices, while internet working refers to the connection of multiple quantum networks to form a large network. Quantum networking and internet working have the potential to enable secure communication, faster computation, and new forms of information processing. This is about introduction of quantum networking and quantum internet working. It is about the first slide. We go to the next slide. Now, this slide is saying about the information quantum communication. Quantum communication uses quantum properties to transmit information securely. It relies on the principles of quantum entanglement and superposition to encode and transmit information. Quantum communication can provide perfect security as any attempt to intercept or measure the transmitted information will disturb the quantum state and be detected. Small picture we have at the right side, it is quantum computing, communication and information. Now, this third slide is saying about quantum key distribution. Quantum key distribution, or it is shortcutly called as QKD, is a method of generating and distributing cryptographic keys using quantum communication. Quantum key distribution enables two parties to establish a shared secret key that can be used for secure communication. Quantum key distribution is secure against any eavesdropper as any attempt to intercept or measure the quantum signal will disturb the quantum state and be detected. On the right side, we have another picture about quantum key distribution is requires two channels. One quantum channel is nothing but subject to adversary and or noises, and one more is one public channel, authentic, unjammable, subject to eavesdropping. And we have Elise, Eve, Bob. Elise is nothing but the sender, and the Eve is the eavesdropper, and the Bob is the receiver. We have from like flowchart here. It is transform into plain text to encryption algorithm, and from quantum state generator to key, it again goes to encryption algorithm, and from public channel, that is telephone or internet, the encryption algorithm will goes into the description algorithm, and through quantum channel, that is optical fiber or free space, the quantum state generator goes into the quantum state detector. And in the Bob, we have quantum state detector through keys, it goes to description algorithm, and last it goes to plain text. So this slide is about quantum key distribution, how it distributes one form to another. And in this slide, we have quantum networks. Quantum networks are networks of interconnected quantum devices that can transmit and process quantum information. Quantum networks can enable secure communication, quantum teleportation, and distributed quantum. Quantum networks are networks of interconnected quantum devices that can transmit and process quantum information. Quantum networks can enable secure communication, quantum teleportation, and distributed quantum computation. Quantum networks require specialized hardware and protocols to ensure the integrity and security of the transmitted quantum information. On the right side, we have some diagrammatic form. It's from pump to nonlinear crystal through x square signal and another form. We can understand through this diagram. Now we come to the main topic of our quantum internet. The quantum internet is a proposed global network of interconnected quantum networks. It would enable secure communication and distributed quantum computation on a global scale. The development of the quantum internet is still in its early stages, but several research initiatives are underway to make it a reality. As quantum networks form an important element of quantum computing and quantum communication systems, quantum networks facilitate the transmission of information in the form of quantum bits, also called qubits, between physically separated quantum processors. The quantum internet is a network of quantum computers that will someday send, compute, and receive information encoded in quantum states. The quantum internet will not replace the modern or classical internet. Instead, it will provide new functionalities such as quantum cryptography and quantum cloud computing. Now we discuss about the quantum cloud computing. Quantum cloud computing refers to the use of remote quantum computing resources over a network. It enables users to access and use quantum computers and simulators without the need for specialized hardware or expertise. Quantum cloud computing can accelerate the development and deployment of quantum applications and algorithms. The cloud-based quantum computing is the invocation of quantum simulators, or processors through the cloud. Increasingly, cloud services are being looked on as the method for providing access to quantum processing. A cloud quantum computer is a quantum computer that can be accessed in a cloud environment through a network. Today, there are a number of quantum computing services that can be accessed by users. They are used to solve complex problems that require powerful computing. So, this slide describes about or discuss about quantum interoperability. Quantum interoperability refers to the ability of different quantum systems to communicate and exchange information. It is essential for the development of a global quantum network and the realization of quantum internet. Several initiatives are underway to develop standards and protocols for quantum interoperability. So on the right side we have a diagram. It is about our what is meant by interoperability. The understanding and prediction of materials properties and their de novo design and widespread research activities in science and engineering. contributing to the development of new technologies with impacts in quantum information science, energy, health, and national security. Computational materials science is now recognized as an integral part of the innovative process leading to materials discovery and design, and the developments of predictive simulation frameworks at various length scales as well as of databases for materials have flourished in the last 2 decades. Now, what is about quantum security? Quantum security refers to the use of quantum technology to ensure the security of information and communication. It includes quantum key distribution, quantum random number generation, and quantum cryptography. Quantum security is essential for protecting sensitive and confidential information in the era of quantum computing. So here we have quantum transmitter 1, quantum transmitter 2, and quantum transmitter so on up to n. It uses only cheap components as laser, comma modulator at customer. These quantum transmitters will transmit into the quantum key, and we have on the right side quantum receiver. Locate expensive compounds photodetector. Quantum cryptography is a system that is completely secure against being compromised without the knowledge of the message sender or the receivers. That is, it is impossible to copy or view data encoded in a quantum state without alerting the sender or receiver. The quantum key distribution, the most widely studied and viable method of quantum cryptography, uses a series of photons to transmit a secret random sequence known as the key. By comparing measurements taken at either end of the transmission, users will know if the key has been compromised. Now we have the challenges and opportunities of quantum networking and quantum internet working. Quantum networking and internet working face several challenges, including the development of reliable hardware, protocols, and standards. However, they also offer significant opportunities for innovation, discovery, and societal impact. The development of quantum networking and internet working requires collaboration between academia, industry, and government. The five most significant challenges facing quantum cryptography are: the five challenges are maintaining a quantum communication network. Challenge 2 is transferring quantum states, and the challenge 3 is a means for secure encryption. The challenge 4 is public trust, and the challenge 5 is sharing infrastructure. These are the five most significant challenges facing by quantum cryptography. Before going to conclusion, we still more about discuss about some challenges overview. The first challenge is maintaining a quantum communication network. The cost of creating and maintaining a quantum communication network is a significant factor that needs to be addressed. Using existing legacy communication infrastructure is a less expensive approach. However, this is not an option for quantum cryptography, as the data rate for existing infrastructure is much lower than the Nyquist rate, limiting the maximum number of photons per second that can be sent. The best way to overcome this limitation is to use quantum states capable of traveling over longer distances, which requires a new high-grade single photon source, and the adoption and development of the more cost-effective networks. And the conclusion is quantum networking and internet working. The conclusion is quantum networking and internet working are emerging technologies that promise to revolutionize the way we communicate and process information. They offer significant opportunities for quantum computation, secure communication, and new forms of information processing. The development of quantum networking and internet working requires interdisciplinary collaboration and sustained investment in research and development. So, this is about quantum networking and quantum internet working. I hope you understand what is mean by quantum networking and what is mean by quantum internet working through these my slides. So, thank you. And some references are from this quantum internet alliance and quantum science and engineering center and quantum exchange, quantum safe security. So these are from references I have taken from. This is about this, nothing. And classical physics, the collection of theories that existed before the advent of quantum mechanics, describes many aspects of nature at an ordinary scale, but is not sufficient for describing them at small scales. Most theories in classical physics can be derived from quantum mechanics as an approximation valid at large scale. So this is some information about classical physics. I hope you understand. Thank you.